Jai Hind everyone. Today we are going to start with the topic that is dynamic memory allocation in C programming language. So before going to start the topic that is dynamic memory allocation, first let us understand what is the difference in between heap and stack management. When we talk about stack, which is a place in the computer memory where all the variables that are declared and initialized before runtime are stored, while on the other hand we are having another memory area, that is a heap, which is the section of the computer memory where all the variables created or initialized at runtime are stored. It is very important for us to understand what is a stack and what is a heap, right? Because in the dynamic memory allocation, when we are talking about allocating the memory dynamically, so we must understand what memory area we are using, right? For that we are using heap, and yes, we have seen before the runtime, if we are talking about the data structure that is being used is stack. So first we need to understand what is the static memory allocation. Then we'll be able to understand what is a dynamic memory allocation, right? So what is a static memory allocation? Static allocation is what happens when you declare a static or a global variable. Fine. In an array, it is must to specify the size of the array while declaring. So the size of this array will be fixed during runtime. How it is so? How we are declaring? For example, I am declaring an array of type integer and say this is the dimension, right? So here I can have an integer array with 200 dimension, right? So each static or global variable defines one block of space of a fixed size. The space is allocated once when your program is started, and the major drawback with this static allocation is the space which has been allocated is never freed, right? We have no option to release the memory once we are done with our execution, right? So here the dynamic memory allocation takes place. Dynamic memory allocation is a technique in which programs determine as they are running where to store some information. Fine. We need dynamic allocation when the amount of memory we may require, it is depending on the factors that are not known before the program runs. That means dynamically, whenever we will be required, we can allocate the memory according to the requirement, right? The allocation and the major advantage, another advantage, release of the memory space can be done with the help of some of the built-in functions whose prototype are found in alloc.h header file and stdlib.h header files, right? These functions take memory from the memory area called heap. As we have seen what is the role of heap while we are talking about dynamic memory allocation, and release this memory whenever it is not required, as simple as that, right? So that's what in the beginning we have seen, that when we are talking about the static memory allocation, we are allocating a fixed amount of memory before the execution of the program, and this memory we are not going to release. But in the case of dynamic memory allocation, we can dynamically allocate memory and we can release this memory whenever it is not required. Fine. We can access the dynamically allocated memory only through the pointers. That means we will be using the pointers within our program to dynamically allocating the memory. So here we have the dynamic memory allocation functions, dynamic memory functions. These are MALLOC, number 1. Then second we have, that is CALLOC. Then third, ReAlloc, and the last one, free. MALLOC, as the name is indicating, memory allocation, right? When we say memory allocation, what obvious, this function is used to allocate the memory dynamically, right? CALLOC, another method of allocating the memory, we can resize. ReAlloc for reallocating the memory, and the free to release the memory, right? So now we will be discussing one by one each and every function. So number 1, that is MALLOC, memory allocation. For memory allocation, this function we are using. This function is used to allocate memory dynamically, number 1, and the prime most important usefulness of this function. The argument size specifies the number of bytes to be allocated. On success, MALLOC returns a pointer to the first byte of the allocated memory, right? If there is not sufficient memory available in the heap, then MALLOC returns null. If the memory is available, if it is a success, then what MALLOC will return? It will return a pointer to the first byte of the allocated memory, whatever memory allocation, memory area we are allocating, right? But in case if there is not sufficient memory available in the heap, then it will return null. Fine. The return pointer is of type void. It is important to understand for us, which can be typecasted to an appropriate type of a pointer, right? Appropriate type of a pointer, that means for whatever type of variable we are trying to occupy the memory, allocating the memory, accordingly that will be typecasted. But by default, the return type of the pointer is void. Fine. So generally we can use MALLOC function like this. Say PTR, that is a pointer variable. Fine. Then we have to specify which data type we are going to use and what type of memory allocation will be done. Then MALLOC, the function, and the specified size, right? So what is the benefit? Program can request a specific amount of memory and retain that memory exactly as long as needed. Whenever we do not require that memory, instantly we can release the memory by using a free function, right? Which we are going to discuss in the upcoming slides. So let's look at the MALLOC statement. Then we are writing a data type, then a MALLOC function, and then size of the block. So what does it mean? When suppose we have taken an example of character. So what it is indicating? This is a typecasting. Why it is so? Because we have seen by default the pointer returns of type void. That is of type void, and it needs to be typecasted according to the requirement, right? So this is a typecasting that forces the variable to the right type. Fine. Okay, then this is a MALLOC function. Yes, we know. And into size of data type. If we are using char, okay, size of char. If we are using int, okay, size of int, and so on. Whatever number of blocks you want to allocate, that is this number, and multiply by size of that particular data type, right? So we want n character. This n says, okay, size of what? Size of a char. Returns how much memory a character takes, right? So this says, in fact, grab me enough memory for n characters. What does it mean by this statement? This statement is saying, grab me enough memory for n characters, right? N is, this is a number n, and this is a size of particular type. If it is char, we'll take char. If it is of type integer, float, and so on, accordingly we can include over here, right? For example, we have declared an integer pointer, say pointer variable ptr, and then we are trying to allocate this 10 blocks. Fine. What it will return on success, it will return to the first byte of the allocated memory area, right? So this allocates 10 contiguous bytes of memory space, and the address of first byte is stored in the pointer variable ptr, right? This space can hold 5 integers, right? If the integer is taking 2 bytes, so 2 into 5, that means it is going to hold the 5 integers. The allocated memory contains garbage value. Okay, that was the example where we have seen that was a success. That means memory was available and it has been allocated. Now, what in case if the memory area, if the memory is not available, what will happen? If there is not sufficient memory available in the heap, then we have seen in the previous slide, malloc returns null, right? So it becomes important to us, or you can say it becomes necessary to check whether the memory is available or not, right? So we should always check the value returned by the malloc. How we are going to check? Okay, we have allocated the memory area. Fine. Say this time we are taking float type of a value. So again, that needs to be typecasted to float type, right? And into size of data type. And what is that? Okay, 10 blocks, 10 into size of float. Now we say if the sufficient area, memory area or memory space is not available, what it will do? It will check ptr equals to null, address of first byte, right, of the allocated memory. But we are saying, we are assuming a case when the memory is not available. That means what it will return? It will return null. So what is the value of ptr? The value of ptr will now become null. If it is null, then we will print a message simply, sufficient memory not available, right? So that's how we can check whether it is returning some value or the address of a first byte, you can say, or it is returning null. So here we have example with the help of which we are going to understand the use of malloc function, right? So in this case we have seen, okay, we are asking a user to enter some of the number of students, right? And we have taken an input of n from the user. Now we are trying to allocate the memory, say n into 2, right? Why it is so? Because we have taken an integer and we assume integer takes 2 bytes. Okay, if the value of this pointer p is what? P is a pointer variable. If the value of this pointer variable p is equal to null after executing this statement, if it is returning null, simply display a message sufficient memory not available and exit, right? Otherwise it will check for the numbers, right? So whatever the value of p is there, p plus I, p is what? P is a pointer variable. When we increment it by 1 and it is of type integer, and if I say integer take 2 bytes, so it will be incremented by 2 instead of 1, right? Suppose the address is 1000, then increment by 1 says increment by 2, so it will become 1002, 1004 and so on, right? So that is how we can store the values on this address, right? Then yes, we have applied this asterisk sign. What it says? It simply says what is the value at this address, right? Sum plus value at this address, right? So that will be a summation. Now once I've got the summation, I can simply divide this by n and now we can check, we can find out the average, right? So average marks is equal to what? Whatever average I have calculated from there, I can display that, right? So this is a simple example of MALLOC function. Now the second function we have, that is a CALLOC, which allows us to allocate multiple blocks of memory, right? It is similar to MALLOC except two differences. First one, it takes two arguments. Right? In the case of MALLOC, we have seen MALLOC takes one argument, size of data type. Here it takes two arguments. One is n, second is size, right? N is the number of blocks and the second argument, size, is the size of each block. Fine. This is the difference in MALLOC and CALLOC. First of all, MALLOC take one argument, CALLOC takes two arguments, right? Unlike MALLOC, CALLOC guarantees that memory contents are all zeros instead of a garbage value, right? For example, allocate an array of 10 elements. So again, I have declared a pointer variable, say pointer IP, and then yes, it is what? A typecasting from void to integer type. Now CALLOC n comma size of data type. So n, suppose I am going to allocate the size for the 10 elements, 10 into size of integer. Fine. So like MALLOC, CALLOC also returns null if there is not sufficient memory available, right? Likewise, in the case of MALLOC, we have seen MALLOC returns null if it is not having it, the sufficient memory is not available, it is not allocated any memory, then it returns null, right? Same here in the case of CALLOC as well, it also returns null if there is not sufficient memory area available, right? Now we have another function, that is realloc. Realloc is what? Reallocation. Reallocation, what says? That means this function is used to change the size of a memory block. Like we have allocated some block of memory earlier and then now again we want to reallocate the memory area, then we can use realloc function. So this is a syntax for the realloc function. How we can use? Again a pointer variable, then the type, realloc the function, then what is the old pointer value, comma, size, right? So what this function is doing, how it is performing? The function realloc is used to change the size of the memory block. What does it mean by changing a size of a memory block? As simple as that, it alters the size of the memory block without losing, this is important to note, without losing the old data. It is not like if we are reallocating the memory space, the older one will be vanished. Not like that. What it will do? It alters the size of the memory block without losing the old data. This is known as the reallocation of the memory, right? Reallocation, that means it is modifying or it is altering the size of the memory block which has previously been allocated maybe by CALLOC or by MALLOC or a CALLOC function. This function takes two arguments, like we can see over here. One is old pointer, second is size. So first is the pointer to the block of memory that was previously allocated by either MALLOC function or CALLOC function, right? So that's why we are saying ki old PTR, old value of a pointer, fine. And what is the second argument? Second is the new size for that block. What was the older value? What is the newer value which it requires, right? This is a syntax, or you can say an example. Say here we have seen a void type, here a pointer variable we have taken, the data type that is integer we are using over here, realloc function, then old PTR, old pointer value, and new size, what it needs to going to alter, right? So old pointer value and new size. On failure, realloc also return null. Likewise, we have seen in the case of MALLOC, we have seen MALLOC returns null when if sufficient memory space is not available in the case of MALLOC. Same for CALLOC as well. Also on failure, or you can say the memory space is not available, returns null. Here as well, on failure, realloc also returns null. Here this is a small program to understand the functionality of realloc function, right? So in this case, in this example, we have seen that we have allocated a memory with this MALLOC function, where how much amount of memory we are going to allocate, that is 5 into size of integer, right? 5 blocks, fine. That means we can say space for the 5 integers. If it is returning, if the value it is returning that is null, that means if the sufficient area, memory area is not available, memory space is not available, then simply we will be displaying the message sufficient memory not available and exit. As simple as that, right? Now, if the memory is available, that will be allocated, okay. Now, I require a memory for 4 more integers, right? Okay. So earlier, what was the memory we were trying to allocate? That was 5 blocks, okay. Now I say allocate memory for 4 more integers. Allocate memory for 4 more integers. So earlier it was 5. Now again we are trying to allocate space for 4 more integers. So now it becomes 9. Fine. So we will be using 9 over here. We will not be using 4. Okay, for the 5 blocks we have already allocated, so we require 4 more. No. What is the total size? That is like 9. So we will be writing realloc old pointer. What is the old pointer? Here PTR is the old pointer. Fine. Comma 9 into size of int. That means 5 earlier I have allocated. For more 4 more integers I require. So for that 5 plus 4 it becomes 9. So 9 into size of integer. Right. So that is how we are using the realloc function. Now again we will check whether this function is returning a success or it is returning a null. That means if the memory space is not available, what it will do? It will simply return some null value. So again we will be having a condition if ptr equals to null, then sufficient memory not available, just print the message and exit, right? Otherwise it will be, the memory will be allocated and it will return to the address of first byte, and now I can use all those allocated memory space as well. Fine. So I hope it is clear to everyone. And yes, here we have the last DMA function, that is free. Free, as the name is indicating, again it is going to release the memory which has already been allocated either by MALLOC or CALLOC function, right? So what is the syntax? Simply we will be using free function for that, free, and within the parenthesis we will be including that pointer variable which is holding the address of that memory area. Fine. So the dynamically allocated memory is not automatically released. It is very important to understand. The dynamic memory dynamically allocated memory is not automatically released. It will exist till the end of the program. It will exist till end of the program. Fine. The function free is used to release the memory space allocated dynamically, right? So simply we need to write free function, and within the parenthesis we will be writing that pointer variable name. So what is the pointer variable name we are using? In the last example we have seen a pointer variable ptr. So we have written free and within the parenthesis ptr. Suppose here I am taking a pointer variable p, then what variable name we will be writing? Free, and then simply that pointer variable, right? So that is how we can use these dynamic memory functions. Either we are allocating or deallocating, or we can say release. The following 4 dynamic memory functions can be found in stdlib.library. To allocate a memory block, we can use either MALLOC or CALLOC. To reallocate a memory block, we have seen realloc function, and to deallocate previously allocated memory, we simply use free function. Fine. So here few of the common errors are there which generally may arise. Number 1, allocation failure. Memory allocation is not guaranteed to be succeed if there is no check for successful allocation implemented, right? So this usually leads to a crash of the program or maybe the entire system. Second is memory leaks. What it says, failure to deallocate memory using free leads to buildup of memory, that is non-reusable memory, which is no longer used by the program, right? So this wastes memory resources and can lead to allocation failures when these resources are exhausted. This is the another common error. And the next is logical error. All allocations must follow the same pattern. That means allocation using MALLOC, usage to store data, deallocation of variables using deallocation of memory using free function, failures to adhere to this pattern such as memory usage after call to a free or before call to a MALLOC, calling free twice, and so on. So usually leads to the crash of the program. So these are some of the common errors. And here I am having a few of the references from where I have included the content within my slides. Thank you.